Now, where did we stop last Thursday? We stopped at the free body diagram here. And I have, after the last lecture, I've filled in the free body diagram like this. Remember that in a free body diagram, we should only have a rigid body, okay? So let me show you a counter example. Analyze rigid bodies only that we mentioned last Thursday. And we have a counter example, which is in Chinese is 反例. So in a counter example, this one is not a rigid body. And if we do not have a rigid body, then we have more unknowns than equations. Okay. Here this is on page 49. Page 49. That's if we don't have a rigid body in a free body diagram, that means we have more unknowns. We have 4 unknowns here, but we only have 3 equations. It's okay. So remember that in a this is not a rigid body, right? So this one we can this is the pin joint and we can rotate. So this is not a rigid body. And these are rigid bodies. So we have one free body diagram and 2 free body diagrams. So if a machine is not a rigid body, break it down into rigid bodies. So we have only rigid bodies here. And as a revision, so by action and so for here that we have a rigid body and we have because we have joints, so we have forces from BCD acting on ABE. This is at joint B, so we have Px and By because it is a pin joint. So for this BCD, it cannot move to the left and to the right, so we have a force here, and it cannot move up and down, so we have a force here, so we have Vx and Vy. And by action and reaction, so for force acting by BCD or ABE, we have to the right and to go up. And so for when we look at BCD, the force acting from ABE to BCD is to the left and downwards. Okay, so this pair is action and reaction. So I think you know the Chinese. Right. I assume you know the Chinese, and this is this form a pair, and for Cx and Cy, because this is the first time we draw this, so we keep it to the right and to go upwards, and this is 2.4 kilonewton going down. So any problem with this free body diagram? And for the dimensions, and forgot the dimensions. And this one is 2.4 meter. This is 1.2 meter. Remember, and for those, I'm not sure whether if all of you were here last Thursday, these two are 2.7 meters. These are 2.7 meters. Now, if you are okay with the free body diagram, let's go to writing down the equations. How many equations can we write from this free body diagram? How many equations? 1, 2, 3, 4. How many? We have summation fx equal to 0. We have what else? Any other? have Fy equal to 0, and we have summation M equal to 0. Let's take point B as this example. So I need to move this. Okay. Now, if we have these three equations, we can write the following: that Cx minus Bx equal to 0. And let's write this is equation 4. And then Cy minus By minus 2.4 kilonewton is equal to 0. This is equation 5. And for summation MB equal to 0, we have minus 2.7 meter Ax equal to 0. This is equation 6. Yeah. Sorry. What? Oh, sorry. Sorry. I written down the wrong thing. So this is 2.4 meters Cy minus 3.6 meter times 2.4 kilonewton is equal to 0. Let me make it a bit bigger. It's okay. Does it look okay? So there are 3 more equations coming from this free body diagram. Remember that for each free body diagram, we should for rigid body we can write 3 equations. We write 3 equations for each free body diagram. So for the free body diagram above, we write equations 1, 2, 3, and for this free body diagram, we write 4, 5, 6. Now and you can do the rest. The rest means 余下的哈，就剩下的。The rest is only calculations from equation 4. We get C equal to 0, and from equation 6 and equation 5 and equation 2, so we can get you can get the rest. It's okay. Now, if you are finished writing these, that you can go to the next page, and please take time to write this down. And if you are done, then go to the next page and see if you know what does it mean. Now we go to the next page, and it is problem 6.1218. So, and in this question, that there is a frame here. There's a frame. So, and these two members are L-shaped. L-shaped members and connected by two rigid links. This is a rigid body and this is rigid body. And for this one, that determine the reaction as supports and indicate. And whether the frame is rigid, okay? So we don't know whether this is a rigid body, and we want to show is this a rigid body or it is not a rigid body. Okay, we don't know if this is a rigid body. So we want to show it is a rigid body or it is not a rigid body. Whether is so I will talk about this part. So your answer, if we ask if there is an exam question, say whether it is something that your answer should be there should be a yes or no. Okay. In your answer, there should be somewhere that you write it's a rigid body or it is not a rigid body. So how do we show that a frame is rigid body or it is not a rigid body? So let's say assume a frame is not rigid if this is not a rigid body, and if P is equal to P is not equal to 0, would lead to that a violation of equilibrium condition that we cannot write the summation F equal to 0. That's the first thing. The second thing is any of the support forces AX, AY, BX, BY, T1, and T2 will become infinite. Okay, if it is if this frame is not rigid and P is not equal to 0, it will lead to Fx or Fy always not equal to 0. Or that any of these support forces at A or at B or these two tensions become infinite, 无限大。Okay, it's okay. Now, so of course this question is a bit difficult, but let's work on it. And the first thing we can do, what's the first thing we can do? That we can draw free body diagrams. Okay, and remember that can we draw the free body diagram of the whole structure? We don't know, but because we don't know whether it is a rigid body, we don't. It may be a rigid body, it may not be a rigid body. So we draw free body diagrams only of rigid bodies. So let's draw the rigid body of this part of the left L and the right L. Okay. We draw this the L shape here, and we draw the L shape here. Now, and this is point A, and this is point B, right? Now at point A we have a pin support, so we have AX and AY. And how about at point B? What forces do we have? Because it's a pin joint, does it go to the left and to the right? No. So we have Bx. Does it go up and down? It does not go up and down, so we have By. Now, and let's say we have four. Let's mark 4 points here. C, D, E, F here. What forces do we have at C? This is a pin joint, right? It cannot go left or right, so we have. I will change it later. 我等一下会换了。So let's say we have Cx and we have Cy. I will change it in a minute. Okay. Let's say we have Cx and we have Cy, and for D we have Dx and Dy because these are pin joint, right? All of these are pin joints. I'll change this in a minute. Okay. 大家先画，我等一下会改啊。So one of your classmates asked a very good question. I will explain in a minute. So let's finish doing this first. So now these are pin joints, right? Cx and Cy, Dx and Dy. But let's look at one thing. We look at what is in between ACE and BDF. There is a rigid link called CD, right? Right, this is called CD, right? What kind of structure it is? Is this a 2-force body, 3-force body, or something else? Is this a 2-force body, 3-force body, or something else? Some other things. All forces act on point C or point D, so it is a 2-force body. The same goes to EF. Okay. If it is a 2-force body, what do we know? Very good. So all the forces would act along the line of CD. So all the forces only act on the line of CD. So usually we write TCD, right? TCD and TCD. Because it is a 2-force body, so all the forces acting on C and D act on the line of CD. It's okay. If we only look at this part. Here, do we have on CD? On CD, do we have forces in y direction? Do we have forces in this direction or this direction? No, we only have the forces in x direction, to the left or to the right. We do not have forces going up and down. So here, we do not, since there is no force going up or going down, so we actually do not have dy here. We only have force in x direction. And because we write TCD to the right, so here we write TCD to the left. Okay, we of course at the beginning we have dx and dy, but after we look at this two force body, we say we only have a force to the right, so here we only have a force to the left. Let's finish drawing the Fermat diagram, and I will talk a bit more about this. And it's the same on the left, and because we have TCD to the left, here we have a TCD to the right. The same thing goes to TEF below.